1985, number 38. So we're told, we know that the first and second derivative exists everywhere, because if it's continuous, then it exists. And we're told that f is smaller than g. And we're comparing the integral of f compared to the integral of g. Well, what does the integral tell us? It tells us the net area, right? So if g is bigger than f, the net area of g has to be bigger than the net area of f, because it's a bigger function, so it has to have bigger area. So this is definitely true. Okay, here's the big question. G must be bigger than f, so I'm going to draw a function g. There's g. So if I draw f, I need to be underneath down here. What does g prime and f prime tell me? It tells me the slope of the tangent line, right? Can a function down here be steeper than this function? Yeah, right? I could draw a really steep graph that's underneath g. Well, obviously the slope there is much bigger than the slope there. So this derivative can be bigger than that derivative. So g doesn't have to have a bigger derivative. Just because your function's bigger doesn't mean your derivative is bigger. Your derivative is a slope. See, what's the slope right there? 0? I could draw a function underneath with a bigger slope. There's a bigger slope for f. See, the slope's bigger? So that does not have to be true. Just because your function's bigger doesn't mean your derivative is bigger. And then what does a second derivative tell you about a graph? It tells you concavity, right? Well, let's look at this. This is like, okay, let's do this. This is saying that the second derivative must be bigger. Well, let's do this. What's the second derivative right here? Don't you agree the second derivative is negative because it's concave down? So the question is, can I draw a function below that that's concave up? Yeah. If I call that f of x, right here, concave up. The second derivative is positive here. Here, the second derivative is negative because it's concave down. So just because a function has bigger values doesn't mean the second derivative must be bigger. Because clearly here the second derivative is negative, here the second derivative is positive. The second derivative of f is bigger than the second derivative of g. So it's not true that the second derivative must be bigger. So the only one that's true is 3. I love that question. I love it a lot.